Hi there and welcome to lesson 1 in our final physics topic, P6, which is electricity for gadgets. And in this lesson we're going to be looking at resistance in ohmic resistors and in non-ohmic resistors. We'll start by looking at some components or symbols for electrical circuits. Anyway, I hope you enjoy the lesson and I will see you at the end. Bye-bye.
So let's have a look at our objectives for our first lesson in our final P6 topic. So by the end of the lesson on resisting, you should know and understand how resistance in electrical systems can change under different conditions. Now before we start, we're going to go through some common electrical components, some of which you'll be familiar with and some of which you might not have come across before, but we will be coming across all of these throughout this topic, and it's just essential that we know what they are. So we're going to start with the common ones that we've probably seen before. If we start with the cell here, where we've got the large line and then the slightly shorter, fatter line next to it. Now that's our power supply. Up here we've got our battery, which is made up of two cells joined together. We then have a light bulb. Again, that's a common one that we will have seen before. Then we can move on to our switch, which is open. If it's closed, it will be between the two circles. We've then got a resistor, and then underneath we have a variable resistor that goes with a line through the middle, or an arrow through the middle, to say that this resistance here can change. Now we've then got a type of resistor called a thermistor. So we've got the line that goes almost like a tick, and then we've got the LDR, which is a light dependent resistor, where we have the lines hitting our resistor here. Now above the resistor we've got the two types of power supply. We've got a DC power supply and we've got an AC power supply. We've then got a relay switch that has the symbols here, the two components to it. We then have a diode and a light emitting diode, where you can see that the diode shape is the same, except we've got the light coming out. So we've got light here and light here. Okay, so we do need to be aware of these, and these will be coming up throughout this topic. Now throughout this topic we are going to be looking at resistors. Now with resistors, they resist the flow of current, so therefore stops that flow going through. So if we have a high resistance, then we have a low current, and if we have a low resistance, we'll have a high current. Now with a variable resistor you can control the currents going through it, so you can increase and decrease that resistance, therefore changing the current that goes through. Now with that, it can change the current and therefore perhaps change the output of your circuit. For example, varying the bulb brightness in a light bulb. It could also vary the speed in a motor as well. Now with resistance, there's also a mathematical approach to measuring that, and that is using Ohm's law. Now Ohm's law is a mathematical relationship between four different component parts, and these are voltage, current and resistance. So we have voltage, which is measured in V for volts, current, which is measured in A for amps, and resistance, which is measured in ohms, which has the symbol omega and not oh my god. Now ohmic resistance means that as the current increases, the voltage will increase as well. Now the current is the flow of what we call charge carriers. and the charge carriers are electrons. Now, Ohm's law has a relationship, and the relationship is this. Resistance is equal to voltage divided by current. Now, resistance is equal to V over I, so R is equal to V over I. Now, it's important to know this. You will be given this formula in the exam, however, you do need to be able to rearrange it, and that involves putting it into the triangle. When a wire gets hot, its resistance increases. Now, the hotter it gets, the higher the resistance is. The higher its resistance, the lower the current will be. So the higher the temperature, the higher the resistance. So remember, the higher the resistance, the lower the current, the lower the current, the lower the voltage. Now, resistance is caused by the collision of the charge carriers, the electrons, with the atoms in the component. So more resistance means more collisions with the atoms. Now, as the temperature increases, the number of collisions will increase as well. So the number of collisions between the electrons, the charge carriers, and the atoms within the circuit. Now, as you increase the current, you will also increase the flow of those electrons. So if you've got more electrons moving, you have an increase in the movement of those electrons. Now, an increased movement of electrons will mean that you have more atoms vibrating because you have those more collisions. So remember, increased current means increased collisions. Now, if you have an increase in current, an increase in collisions, that will then cause an increase in the temperature. So not only will increase in the temperature increase the collisions and therefore increase the current, you can increase the current will increase the collisions and therefore increase the temperature. Now here we've got the resistance showing of two what we call ohmic resistors. Now, ohmic resistors show that as the current increases, the voltage increases, which is what we can see here. Now, this happens in a linear fashion, which is why we have this straight line. Now, what we're going to do is look at how the resistance changes between this one here and this one here. Now, on the graph, what we've done is we've got the change in the current. So we've got delta, which means change, Greek letter delta, in current, which is I, and 1 for this resistor number 1. And then we've got our change in voltage. So we've got delta, change, V for voltage, and R for 1. Now we can work out the resistance by using Ohm's law. So the change in voltage divided by the change in current will give our resistance for resistance number 1. Now if we look at the second resistor, we can see that we have the same with the delta, so the change in current for resistance 2 and the change in voltage for resistor number 2. So we can put that into our Ohm's law calculation and we can come up with this result. So let's put some values to this. So if our change in current on R1 is 2 and our change in voltage is 6 that we put in here, so that is 6 there and 2 for here, we end up with a resistance of 3 ohms. Now if we do the same for resistor number 2, where this time we have a change in current of 4, so that's a bigger change in current, and then our change in voltage is 2, so current 4, voltage 2, we do that and we end up with a resistance of 0.5. So we can quite clearly see that our resistance in number 1 is a lot higher than the resistance in number 2, and that's for ohmic resistors which have that linear relationship. So let's have a look now at non-ohmic resistors. Now non-ohmic resistors have a slightly different shape. They have a non-linear curved relationship. So again, as the current increases, the voltage increases, but it increases exponentially. Now what we can do to work out the resistance on here is we can take a tangent line. So when we put the tangent on, we can then work out the gradient of that particular tangent, and therefore the current down here and the voltage down here. Now we can also do exactly the same further up the current. So as we increase the current, we can find out what the resistance is higher up. Now what you might be able to recognise from when we did it with ohmic, the steeper the line, the higher the resistance. So this one will have a lower resistance than here. So we can see that as the current increases, the resistance will also increase. Now we may find this on this sort of relationship in non-ohmic conductors such as filament light bulbs. Now this might mean that as the current increases, the temperature will increase and therefore the resistance will increase. So this is why we have this relationship.
Okay, so that concludes our first lesson in our final physics topic P6, electricity for gadgets, and our lesson on resisting. Now we have looked at how to calculate resistance using Ohm's law, which involves the equation V over I equals R, and then we've looked at how we can actually calculate resistance of ohmic and non-ohmic conductors by looking at what happens, or the relationship between current and voltage. So what happens when we increase the current, what will happen to the voltage. Now with an ohmic it will be a straight linear line, and with a non-ohmic it will be an exponential curved line. Anyway, I hope you've enjoyed this, and I will see you next time. Take care, bye bye.